Hello, welcome to Lesson 3, Radio Frequency Measurement Fundamentals, the results section. So we're going to look at what kind of results are taken and how these results can be presented and interpreted. So the performance of a device under test, as measured by your vector network analyzer, is a scattering parameter or an S parameter. This tells you the magnitude and phase of the signal. You can take it at a single frequency over a range of frequencies. You can take it as a function of time as it travels along the system. All sorts of different things you can do, but you always come back to working with a raw S parameter, a scattering parameter. There are a few different types of scattering parameters. The most common ones are an S21 and an S11. So we'll go through what on earth that means. You have a two-port vector network analyzer, port 1, port 2. You connect them up to a device under test using a coaxial cable or whatever your transmission line of choice is. An S21 is a through measurement from port 1 to port 2. So you need to read the letters in reverse order. It goes from 1 to 2, so it's an S21. And vice versa. An S11 you can pretty much gather is a reflection measurement. So it is out of port 1 to the device under test, back into port 1. And again, it is in that reverse order. So the first one is your receive, the second one is your transmit in that setup. So how do we display these S11, S21 results that we get? If you talk to electronic engineers or RF people, they'll probably give you a Smith chart to look at, which is a graph as shown here. And the results are plotted on here in different places, mean different things. Top half of the graph is inductive, bottom half is capacitive. If you're over at the right hand side, you've got an open circuit. If you're over at the left hand side, you've got a short circuit. Somewhere in the middle is impedance matched, which is brilliant if you understand all those terms and that's the kind of information that you want. Sometimes this isn't actually particularly useful if you're not deeply into RF measurements, so you can also get it as a magnitude and a phase. The kinds of things that you want to derive from these S parameters that are useful. First one is the gain. This tells you how much power is given to your signal by the system. So particularly useful for antennas. If you've got a transmit antenna, you want to put some more power into that signal before you send it out. It will have a gain of 20 dBs, for example. The return loss tells you how much signal is sent back. So it's a loss because it's lost signal. You want your signal to transmit all the way through and to go out of the system. So that is your through measurement. Your return loss tells you what you send, what proportion of what you send in comes straight back at you. VSWR, voltage standing wave ratio. So this is a really important measurement of impedance matching. This tells you basically how well you have set up your hardware and how well you've matched the discontinuities between the different kinds of transmission line. So the conclusions for this chapter: scattering parameters, S parameters are an important result. You can get these on a Smith chart, you can get them on a Norman graph, you can get them as a number. So if someone presents you with a Smith chart and it means absolutely nothing to you, ask for it in a different format. The gain tells you how much the device increases the power. Okay, so the next chapter we're going to look at different types of RF measurement.